So our final talk from GIST is from Ji-Hun Mun, who came to GIST from Jeonbuk University in Korea and is currently working towards his Ph.D. And he'll be talking about guide image filtering-based disparity range control in stereo vision.
Hello everyone. Thank you for a brief introduction about me. My name is Ji-Hun Mun. I'm from GIST in South Korea. Today's my topic is the guided image filtering-based disparity range control in stereo vision. Here are contents. Firstly, I will briefly explain about the sequential disparity estimation method, and then I will explain the disparity search range restriction method, and also explain about the disparity map update method. And then I will show some experimental results, and finally I will wrap up this presentation in the conclusion step. Firstly, the sequential image contains some movement or some object, and the scene movement is contained in the sequential image. And also the sequential image has some temporal relation with neighbor frames. But because of the many matching cost computation, it is not improper to real-time stereo matching method. So to handle this problem, we propose this flowchart. Firstly, we use the left and right stereo images, and then generally we compute the matching cost, and then you can get the disparity map, and then applying the winner-takes-all method, then you can get some fine disparity map in this step. And based on this fine disparity map, you can restrict the disparity search range in the following frames stereo matching. So you can check that the frame number is different. Here is n. Yes, here is the n plus 2. And in this step, we also use the stereo images in here. And based on this restricted disparity search range, you can get some other matching cost volumes. And based on this matching cost volume, you're applying the guide image filtering to update the disparity map in this step. And then finally, you can get the final disparity map in these frames. This slide shows the graphically explain our proposed method. The proposed method simplify the matching procedure in this step because this initial disparity map restricts the disparity search range in this procedure, and also the proposed method reduces the error propagation problem. The error propagation problem is caused by the disparity search range in the sequential image stereo matching method. So to prevent the error propagation problem, we apply the guided image filtering in this step. By using this guided image filtering, we can accurately generate the disparity map in the following disparity map in this sequence. And from this slide, I will explain how to compute the matching cost to generate the initial disparity map. Firstly, we make the gradient image. So before that, we have to remove some meaningless region, and also we have to remove the detail of the object inside the region. So as a solution of these two issues, we apply the bilateral filter using these equations. In this equation, the W terms defined in this here. If we apply the bilateral filter on these two input images, then you can get this smoothed result. Again, this one is the raw input image, and this one is the bilateral filtered image. And from this smoothed image, we generate the directional gradient information. Especially, we consider the x and y directions. And also, we assume that the image has the RGB vector space like this RGB. And then you consider this gradient information from the raw image and the filtered image. In here, the filtered image represents the guided bilateral filtered result, and we also consider the directional information is the X and Y direction, and the RGB, the through channel. So we compare the complexity of the double gradient method and the conventional gradient method. Here are the same X and Y directional. It's the same with the conventional method and the double gradient method, but there is some difference between the double gradient and conventional gradient method in terms of the RGB channel. This one is the 3 channel, and this one is the gray channel. And also, we use this raw and filtered images. So the double gradient method is more higher complexity than the gradient image. This slide shows the double gradient result. In this sentence, the double means the raw and the filtered image. The gradient extraction in the double RGB channel can preserve the data originality, and also it is robust to the small noise factors. The first row indicates the gradient information which is generated by the raw input image, X and Y direction. And also the second row indicates the gradient image extracted by the filtered X and Y information. And then I also added some other matching cost computation that was the Census Transform. I will briefly explain the Census Transform. If we consider the center pixel, and then we compare the neighbor pixel values, and then if the center pixel value is more higher than the neighbor pixel, then we assign the 1 value. If not, this center pixel is higher than the other neighbor value, then we assign the 0 value. And then you can get this bit stream using the left and right image. And you're applying the XOR computation like this. And then you can get this Hamming distance code like this. This one is the Census Transform concept. And by combining the gradient and the Census Transform and the color computation, we combine this mixed cost computation function. In this equation, we are applying the different weighting factor. This alpha and beta was the 0.5 and 0.45 and 0.3, because the object boundary preserving is more affected by the gradient and the color cost. So that's why we are applying the different weighting factor in this equation. As a result of this matching cost function, you can get those kind of initial disparity map. By using this initial disparity map, you can restrict the disparate search range in the following image stereo matching. And as I mentioned in the first step, the sequential stereo matching has some error propagation problem. So to improve the reference disparity map accuracy, we adapt the guided image filtering, and then the guided image filtering can provide accurate disparate search range. The periodical disparity map update is indicated in these figures. If you're applying the periodically updating the reference disparity map, then you can get those accurate disparity map as a reference disparity map. So because of this reason, you can generate more accurate disparity map in the sequential stereo matching. First of all, we have to make some initial matching cost volume to perform the guided image filtering. The cost volume is generated depending on the disparity search range. For example, we can assume that the disparity search range is from 0 to 63, then the number of generated disparity cost volume is the 64. So as we know this result, that the generated matching cost volume is depending on the disparate search range. And then you can get those undefined cost volumes. Based on this result, you can apply the guided image filtering. However, before that, to accurately perform the guided image filtering, we extract some edge regions because we are applying adaptive weight on these edge regions. So we firstly extract some clear edge regions. So, but in the input image, there are many noise. It affects by the matching cost volume, and also it affects to the edge region extraction result. So to handle this problem, we are applying this image smoothing filtering. This smoothing filter composes these two filters. The first thing is the Gaussian filter. It can remove the small scale factors from the input image. And then we applying the guide image filter. The guide image filter in this step, we can sharpening the Gaussian filtered image, which Gaussian filtered image is coming from the previous step. I will show the explanation about this one. We have some small factors in the raw image. We can zoom in this raw image. Then there is some fluctuation in this edge region, and also the side of book has some little fluctuation, which called the small factors. And also the edge region has some error, and the inside of the object has many texture information. Which one is not we want in the edge extraction result. So we have to remove these regions. This slide shows the overall procedure of the image smoothing method. We use the raw image and the filtered image. In this step, the filtered result is generated by the Gaussian filter, and then we use these two images in this guided image filtering step, and then you can get more sharpened image comparing to this filtered result. And we iteratively perform this procedure until the omega value is converted, until some threshold value converging to this omega value. In here, the omega is the iteration criterion, and it also represents the computation of the SSIM. These slides show the SSIM value computation. In our experiment, we set the omega value 0.96. You can check that if we iteratively perform this image smoothing filter, the SSIM value is gradually increased. You can check this SSIM number in this here. And based on this smoothing filtered result, you can extract some edge region. So in this slide, I compare the Kenny edge detection result. The left image is coming from the raw image applying the Kenny, and right image is the filtered image applying the Kenny. So as you can see in those figures, you can notice that some filtered image can provide more informative edge region comparing to these raw input images. And based on this edge region, we are applying the guided image filter. The guided image filtering is used for the cost aggregation using these equations. By using this equation, the boundary region is well preserved after the guided image filtering, and also it can matching cost volume is optimized by this guided image filter. And we applying the adaptive weight assignment in this guided image filtering procedure. In this term is composed of this GE function and the G function. In this equation, G function is same as this function, and this GE represent this Gaussian filter. We intentionally demolished some edge region to applying the adaptive weight on guided image filter procedure. From this slide, I will show some experimental results. This slide indicates some experimental results using the periodical disparity map updating method. As you can see in those figures, you can notice that there is no error propagation problem. Even though we continuously perform the sequential stereo matching using the restricted disparate search range method. And we also evaluate the performance using the BPR value. And as a comparison method, we compare the previously published paper, which one is the feature-based disparity refresh method. And we can differently set the disparity refresh ratio, as you can see in these tables, 1/3 update and 1/5 update. And you can know that the more frequently updating method can provide more accurate depth map when you're comparing these two numbers in here. And we also compute the computational complexity. The comparison method is the same, the proposed method and the previously invented method. The more frequently updating ratio also take more time than the less updating ratio. As you can see in this figuring number, you can know that it takes more time than this updating ratio. Okay, here's conclusion. In this presentation, I explain the sequential stereo matching method, which restricts the disparate search range, and also it can reduce the cost computational complexity. And to prevent the error propagation problem, we periodically disparate map updating method, which can performed by using the guide image filter, and we also applying the adaptive weighted cost aggregation method. As a result of that, you can improve the BPR performance. However, it also increases the computational complexity in our proposed method. Okay, thank you for attention.